Humanity has now confirmed over 6,000 exoplanets, worlds orbiting other stars. And that number is not the story. It's just the first scratch on the surface. Because in our Milky Way alone, there are hundreds of billions of stars. And evidence suggests most stars don't come alone. They come with planetary systems. Then multiply that by the trillions of galaxies out there, each packed with their own suns and their own worlds. So here's the uncomfortable, thrilling implication. If a planet can exist within the laws of physics, then somewhere out there, it probably does. Not maybe, not in theory. Statistically, reality has had too many chances to roll that dice. And today, I want to take you on a journey to 4 hypothetical worlds that could actually be better for humans than Earth. Not magic, not fantasy. We ran simulations, we obeyed the rules of gravity, climate, and orbital mechanics. These are worlds that are plausible. And as you watch, keep one thought in your mind. Somewhere in the universe, these places are real. Let's go. World 1. Pandora, but real. Our first stop looks like science fiction, but the physics is very real. A habitable moon orbiting a gas giant. A world nearly Earth-sized, but hanging in the gravitational shadow of a massive Jupiter-like planet, parked perfectly inside the star's habitable zone. Now, picture stepping outside. The sky isn't just blue, it's alive. Because sitting there, filling half the heavens, is a planet so huge it doesn't look like an object. It looks like a world hanging above your world. And that alone might make this place feel like the greatest view in the universe. But the real reason this moon could be better than Earth isn't just beauty, it's stability. Here's what makes it special. This moon is tidally locked to the gas giant, meaning one face of the moon always points toward the planet, the way our moon always faces Earth. That sounds like it would create extreme seasons, extreme chaos, but it does the opposite. Because tidal locking can stabilize the moon's axial tilt for millions, maybe billions of years. That matters more than people realize. On Earth, our seasons are reasonable, largely because the moon stabilizes our tilt. Without that, Earth could wobble wildly over long time scales, flipping climates, shifting deserts, triggering ice ages. But on this moon, the tilt stays steady. Seasons stay civilized, no planet-wide climate roulette, and then there's the tidal heating. The gas giant's gravity is constantly stretching and squeezing the moon's interior like a slow heartbeat. If it's not too strong, it becomes a gift. Just enough geothermal activity to keep the interior warm, to drive tectonics gently, to prevent global deep freezes, without turning the surface into a volcanic nightmare. Now here comes the strangest part of daily life. This moon takes 10 days to orbit the gas giant. And because it's tidally locked, that orbital cycle becomes the day. So one sunrise lasts 5 Earth days. Then night falls for 5 Earth days. But night on the near side isn't truly dark, because the gas giant is shining above you like a permanent full-planet lantern. The reflected light could be so bright it washes out the stars, which means the people living on the near side might barely see the universe at all. Until the system aligns. Because once every orbit, the moon may pass through the gas giant's shadow, a solar eclipse so vast and unnatural that it turns day into twilight for hours. Temperatures drop, winds shift, the sky changes color, and for the first time in 10 days, the stars appear. Not gradually, not politely, they just snap into visibility. A whole universe revealed for a few hours, then swallowed again by the light of the planet above. If Earth is a home, this is a home with a God-sized neighbor in the sky. And yes, worlds like this could absolutely exist. We've already seen the building blocks of this scenario in our own solar system. And if you think that sounds unreal, let's go somewhere even stranger. World 2, the Black Sun planet. Now imagine walking outside and seeing something you can't explain. A normal star in the sky, warm, familiar, Yellow. But when you zoom in with an advanced telescope, you notice something wrong. A distortion, a bending of light, a silent gravitational warping near the star, because your star isn't alone. Welcome to a planet orbiting a binary system, a sun-like star, and a stellar mass black hole. The planet itself is Earth-like. Same size, same atmosphere, same gravity, same oceans. But it's bound to a system where one of the suns doesn't shine, it devours. Here's the setup. The star has the mass of our sun. It orbits a black hole about 10 times heavier. That black hole sounds enormous. But here's the mind breaker. A 10 solar mass black hole could be only around tens of kilometers across. Not bigger than a continent, not bigger than Earth, smaller than a city. A gravitational monster compressed into a sphere you could drive across in an hour. From the ground, day-to-day life looks normal. You'd still get daylight from the star. You'd still see clouds. But the sky holds something invisible that changes everything. As the star passes behind the black hole, you could occasionally detect a faint Einstein ring, a halo of warped light caused by the black hole bending the star's glow around it. Now, because the gravity is stronger and the planet must orbit faster to stay in the habitable zone, a year here is short, around 110 days. Seasons come and go fast, calendars feel frantic, and time itself ever so slightly off. Not in the dramatic interstellar way where minutes become decades, but measurable. Your clocks run slower by a few seconds per year compared to an equivalent planet without the black hole's gravity. It's small, but it's real, and it would affect navigation and satellite systems the way relativity already affects GPS on Earth, just more so. Now, tides. On Earth, tides come from the moon primarily, with the sun contributing. On this world, you have the star's gravity and the black hole's gravity. So the ocean is under constant competing pull. You might see tides that are several times stronger, even without a moon. Coasts would be built like fortresses. But why is this world better? Because for a civilization that wants to understand physics, this is heaven. A nearby black hole turns your sky into a laboratory. You could test extreme gravity, measure relativistic effects, observe accretion behavior, study the environment around a black hole without traveling light years. This planet is not peaceful, but it's one of the most valuable scientific locations a species could ever live on. And now, let's go to a system that fixes one of humanity's greatest weaknesses. World 3, the Twin Earths. Here's the brutal truth about Earth. We have no backup. A single asteroid, one runaway climate cascade, one global catastrophe, and the human story can end. So imagine a system designed by nature to solve that. Two Earth-mass planets, sharing the same orbit around a star, not colliding, not chaotic, stable. They move in a strange gravitational dance called a horseshoe orbit. They follow nearly the same orbital path, but one is slightly ahead, one slightly behind. And once every 33 years, the inner one catches up. They pass close, only about 1.5 million kilometers apart. That's close enough that you could see the other planet enormous in the sky. Close enough that, with modern propulsion, a trip between them might take about a week. And at closest approach, gravity does something surreal. They swap positions. Not instantly, not like teleportation. They trade orbital energy. The inner planet moves outward. The outer planet moves inward. Then they separate again and spend decades drifting apart. Life in this system would be civilization changing, because every few decades you get a window. Trade, migration, joint science missions, cultural exchange. You wouldn't be trapped on one fragile world, and the psychological impact would be enormous. You'd look up and see another Earth. Not a point of light, not a star, a world with oceans, a world you could reach. Now, yes, This is exotic, but it's not invented because our solar system has an example of the same physics. Saturn's moons, Janus and Epimetheus, do this exact orbital swap. So if the universe can do it with moons, it can do it with planets. And if that exists somewhere, that might be the best planet system for humanity because it makes extinction harder. It gives our species something we've never had, a second chance built into the sky. Now for the last world, this one is pure visual insanity. World 4, the five-sun world. I'm taking you to a sunrise, but this sunrise is different because on this planet, the sky has five suns. Sounds impossible, right? It isn't. It's just rare. Here's how it works. You build a hierarchical system, like nested orbits. In the center, you have two sun-like stars orbiting each other tightly, almost close enough to touch, but still stable. Your planet orbits around that pair at roughly Earth-Sun distance. If we stopped there, you'd have something like Tatooine. But we keep going. Farther out, you place another pair, red giants, slowly orbiting each other. They circle the central system on long timescales, decades. And farther still, a red supergiant, incredibly distant, taking thousands of years to complete a slow loop. So why doesn't this cook the planet? Because distance controls flux. Even though you have multiple suns, most are far enough away that their energy contribution is small. The combined incoming light can still be tuned to match Earth-like warmth. So this planet can be habitable. But the sky is never normal. Night is rare. True darkness might occur once every year when all the stars happen to dip below the horizon at the same time. Most nights, at least one star is always illuminating something, which means solar farms could run almost continuously. Energy becomes cheap. Civilization becomes powerful. Even shadows become strange. You'd walk outside and see multiple shadows overlapping, pointing different directions at once. Your whole sense of where the light is coming from becomes alien. But there's a dark twist. Those outer giants are short-lived. Red giants and supergiants don't last long on cosmic timescales. They burn fast. They die young. In a few million years, maybe less, one of them explodes as a supernova. And that changes everything. Even if the planet survives the radiation, the mass loss from the supernova reshapes the gravitational system. Orbits destabilize, the architecture breaks, and your world could be flung out into interstellar space. Habitable planet turned into a rogue, drifting in darkness forever. So yes, it's a paradise of light, but the paradise has an expiration date. So those are four worlds that could arguably be better for humans than Earth. A stable moon with a planet filling the sky. A black hole laboratory hiding next to a star. Two Earths that give humanity a built-in backup. And a five-sun world where daylight is almost permanent until the system dies. Now here's my question to you. If you had to pick one, where would you move humanity? Would you choose beauty, science, survival, or power? Drop your answer in the comments. And if you want more journeys like this, more worlds, more physics, more "this should not exist, but it does," subscribe and stay with me. Because out there, these planets aren't just ideas. They're waiting.